Hello friends, this is video number 19 based on the topic solutions. In this video, we are going to learn the one more important article from this chapter, that is what? The colligative properties of electrolytes. Friends, in the preceding videos, we have studied the colligative properties for the solutions of the non-electrolytes into the water. Now, in this case, we are going to learn the colligative properties for the solutions of electrolytes in the water. So, we already know what are the electrolytes and non-electrolytes. The electrolytes, so these are the substances when dissolved in water, they get dissociate or ionize and produce the ions, and therefore now see here like this we know NaCl, CaCl2. So these are the examples of electrolytes. So electrolytes, these are the substances when dissolved in water or in aqueous medium, they produces the ions like this. NaCl dissociate or ionize and produce Na plus and Cl minus ion. Similarly, CaCl2 gives Ca2 plus 2Cl minus ions. While non-electrolytes, so these are the substances do not dissociate or does not dissolve. That is all. They remain in the form of molecules in the solutions. For example, we know sugar, urea. So these are the non-electrolytes. So the dissolution of such substances is shown like this. That is all. The sugar, that is cane sugar or sucrose, C12H22O11 dissolved in water. In this case, it has tendency to recrystallize in the form of molecules like this. So that is all. It remains in the form of molecules. Similar is the case regarding to the urea. So what is difference in this case? That is the properties, colligative properties for electrolytes behaves differently than that of the properties of the non-electrolytes. So in this section, we are going to learn the colligative properties for the electrolytes, the electrolytic substances. So the approach towards the colligative properties towards the electrolytes is different than that of the non-electrolytes, and that's why in this case, while studying the colligative properties of electrolytes, some relations with that of the non-electrolytes of these electrolytes are totally different. That is what the properties not related. Colligative property does not related as that of the non-electrolytes regarding to the electrolytes, and therefore here the few changes which are observed in the properties of the colligative properties with respect to the electrolytic solutions. Now see here, following are the experimental observations for the colligative behavior of electrolytes. So how the colligative behavior for the electrolytic solutions it changes, that is shown here. See, the solutions of electrolytes do not obey the relationships of non-electrolytes. That is what I have already told, that the approach of the colligative properties towards the electrolytes is totally different than that of the non-electrolytes. That's why the solution of electrolytes do not obey the relations of the non-electrolytes. Furthermore, colligative properties of the solutions of electrolytes are greater than those expected for the solutions of non-electrolytes of the same concentration. So again, what is the another change of the colligative properties towards the behavior of electrolytes? So that is what colligative properties of the solutions of the electrolytes are greater than that of the colligative properties of the non-electrolytes in their solutions. That is all. So properties are found to be greater. So we will see why the properties of electrolytic solutions in case of the compared to the solutions of the non-electrolytes, the molecular masses. Now see one more aspect, the molecular masses of electrolytes are found to be lower than the formula masses. See here, the molecular masses of the electrolytes are found to be lower than that of the formula masses. So these are the three different behaviors of the electrolytic solutions or solutions of the electrolytes observed compared to the colligative properties of the solutions of the non-electrolytes. Now see, so in this case what happens, that is what it is observed that the solutions of electrolyte do not obey the relations of non-electrolytes. Colligative properties of the solutions of electrolytes are greater than that of the expected for the solutions of the non-electrolytes, and furthermore the molar masses of the electrolytes are found to be lower than that of the formula masses. So see here, so what happens here, why the colligative properties of electrolytes are greater compared to the colligative properties of the non-electrolytes of the same concentration, the solutions, two solutions having the same concentration, that is the solution of electrolyte and the solution of non-electrolyte in water having the same concentration, even though the colligative properties of the electrolytes in water are found to be greater or higher than that of the colligative properties of the non-electrolytes in the solutions. So this is because we have seen here that is electrolytes dissociates or ionize into the ions, and what happens here now here, that is the molecular masses of the electrolytes are found to be lower than that of the formula unit. See here, so in this case NaCl, for one formula unit, when this electrolyte dissociates, it produces two or more than two ions into the solution, and therefore what happens, that is what the number of ions increases, and we know the colligative properties are depends upon the number of particles, and as in case of electrolytes the number of particles increases. Look at this, so this is regarding to the electrolytes and this is regarding to the non-electrolytes. In case of non-electrolytes, the molecules, that is what the molecules are remains in, or in this case that is the ions formation is not taking place there. Here the ions are formed there, and as a result of that the number of particles increases. Number of particles get double, twice or more than that, like this. So in this case here regarding to this, how the ionization occurs, and therefore in case of this, even though the solutions having the same concentration, for example in case of NaCl, when the 0.1 molar concentration of NaCl is taken, and similarly the urea solution of the same concentration, that is 0.1 molar is taken, in that case it is observed that is the colligative property, any colligative property for this NaCl is found to be double than that of the solution of the electrolyte, urea solution of the non-electrolyte. So in this way, so why such type of change is observed there? See here, the molar masses of the electrolytes are found to be lower than the formula masses. That is what formula unit compared to the molar mass of this, the observed mass is lower because due to the formation of such type ions or dissociation of this NaCl into the solution, and that is why the colligative properties of electrolytes are different than that of the colligative properties of the non-electrolytes. So we have to learn the one more important article based on this, that is what? The Van-'t-Hoff's factor. The Van-'t-Hoff factor gives the relation or comparison between the colligative properties of electrolytes and the colligative properties of the non-electrolytes for the same concentration solution. So that's all. Thank you.